Hello guys and welcome back to Mossy Maths. Today we're going through a GCSE video and we're looking at Pythagoras Theorem. Now this is a topic that comes up in so many areas of maths at GCSE and indeed A level and any other higher level of maths. This is something that's always going to come up. So if you're new to this, it's worth getting to grips with at an early stage because this is something that is likely to come up in future maths. If you want to take it at A level, then this is going to be something that is fundamental to answering exam questions. Now the key points are a squared plus b squared equals c squared. This is the formula we apply. We need to know that the hypotenuse is what we call the longest side of the triangle, which is what we call c in this equation. And we also need to know that this only applies to right-angled triangles, okay? Only right-angled triangles. So any other type of triangle, this is not applicable. So, we start with this question here. We're told to find x, and this is a standard triangle that we might get with lengths 3, 4, and the longest length is x. Now we need to identify that this is indeed the longest length. It's the diagonal, and this is what we call the hypotenuse, okay? Now, this is just a case of putting numbers into an equation to get an answer, okay? So, A and B correspond to the two shorter sides of the triangle. It doesn't matter which one we pick as the shorter side. We could pick 3 or 4 as A or B. It doesn't matter. So I'm going to call the 4A and the 3B. A squared plus B squared equals C squared, and C is the longest length of the triangle, which is called X in this question. So we'll call it X squared. But we could call it C, it doesn't matter. Okay? 4 squared is 16 and 3 squared is 9. So 16 plus 9 equals x squared, which is 25. So x is simply the square root of 25. Okay? We take the square root of 25, which equals 5. Now, some of you will be aware that the square root of 25 can be minus 5 as well. However, in this case, the minus is not relevant because we are looking at a length, and we can't have a negative length, okay? So, x is 5. And that's all we need to do, guys, for Pythagoras. It's as simple as that. We apply a formula to a triangle to find a missing side, and it has to be a right-angled triangle. Now, looking at the second question, it is at an angle, but it doesn't matter. We can see the right angle here, so we can apply Pythagoras. This is length 7 and this 1. Now x is the longest length because it's the diagonal, okay? And we can clearly see that that is the longest side of the triangle. Now, if we square the two shorter sides, we will get x squared, just like in this example. So the 7 squared is 49, and 1 squared is just 1, and this is equal to x squared. So x squared is 50. Now if you're familiar with surds, you'll realise that the square root of 50, which is x, can be simplified. And all we do is we look for square numbers that multiply to give us 50. Well, straight away I can think of 25 and 2. They multiply together to give us 50, and 25 is a square number. So whilst the square root of 2 cannot be simplified, the square root of 25 can. This is just 5 multiplied by root 2. 5 root 2. Now if you're not familiar with surds, then don't worry about this section here. Just worry about the application of this formula. So all you need to know is how we use it to get to an answer. Now with this example here, this one is slightly different. Hopefully you notice that the longest side, C, is actually given to us here. So it's simply a case of rearranging this formula to find x, which is the shorter side in this case. So a squared plus b squared equals c squared. A squared, I'm going to call ax in this case. So x squared plus b squared equals c squared. Now we're trying to find x, so we simply rearrange this for x squared. And we do that by moving the b squared across to the other side. So we get x squared is c squared minus b squared. So this is just c, which is our longest side, 12 squared, minus 9 squared. Okay? And that's all we have to do here. So we get 63 as our x squared. Now again, similar to the previous question, the square root of x squared will give us x, and in this case we can simplify the root of 63 because this is the same as 7 and 9 multiplied together, both square rooted. Now, whilst the square root of 7 cannot be simplified, the square root of 9 can. This is just 3 times root 7. Now with this example, I'd like you to pause the video and have a go for yourself. If you find this relatively straightforward, then that should be enough for this topic. So give this one a go, and I'll go through it with you as soon as you've had a go yourself. Okay guys, hopefully you've paused the video and had a go at this question. Now, again, similar to this question, we're given the longest side, which is 8. We rearrange it as we have here. X squared equals 8 squared minus 5 squared. So it's 64 minus 25, which equals 39. So x is equal to the square root of 39, and I'm going to leave it in this form. So that covers Pythagoras, and hopefully you found that video helpful. If you did, please leave a like, and if you have any questions at all, please leave a comment at the end of the video. Now, this is a relatively basic topic. Once you get used to the questions, they are all very similar. And again, like I said before, this is very important. If you want to go on and study maths at a higher level, this will come up in so many areas. So get to grips with this, and this is a fundamental piece of maths throughout all levels of maths. So, okay guys, thanks a lot for watching the video, and I'll see you in the next lesson.